Hello. So this is a hobby I've taken up pretty recently, and this is my first largish project. Um, so the idea here was to basically make an image display on an LED matrix, and the whole thing uses only basic components like diodes, transistors, a couple of capacitors there, and resistors, and just tons and tons of wire. Um, so let's just go through the bits. Oh, sorry about that. So this first bit is basically my clock. It's just a multi-vibrator. Um, so I have two sets of capacitors here. These small ones are for just running at a high frequency, and these larger ones are just to slow it down to test and stuff. So when I turn this thing on, I will show you it slow with these capacitors in, and then I'll just take them out, and you'll see an image. Well, it's still, ticking along, but it will look like a still image. So these three boards, these are they make up a 3-bit binary counter. So each one of these boards is an edge-triggered D flip-flop. So this one is tied directly to the clock, and then the next one is tied to the output of this. So it's clocked by that one, and it's clocked by this one. So when this one's on, i.e. it's representing a 1, when it flips back, it will represent a 0, but it will trigger this one, which will represent a 1. So you have it counting, and because this is 3 bits, it can count from 0 to 7. So it's a 3-bit binary counter. This bit, this is just a big decoder. So it takes the 3 bits of here and outputs like one signal for 10 different outputs. Sorry, 8 different outputs. So there's 8 outputs here. It's hard to see, but basically these ones on the edge, these are the outputs, and it's only got 3 inputs. So 3 inputs, 8 outputs, and it counts from 0 to 8. And then these go out to this, which is the LED matrix. And what that's actually doing is opening the gates to ground here. So when this one's on, for example, these LEDs will be grounded, so they'll go out there and power can flow through them. And over here, this is, oh God, I can't even see because of the light. Here, it's sort of the memory. It's a bit hacky, but coming to the end of this project, I just wanted it finished. But yeah, this is meant to output the picture, which in this case is a smiley face. So you see there's 8 transistors there, and these go into just loads of cables, which are, hardwired to create the picture. Like they're hardwired to each row, essentially. It's that way around. So yeah, each row. And so what happens is each one of these that is on outputs to a different set of wires which go through to whichever column is grounded. So you can draw bits down here, then you'll draw bits down here, then you'll draw bits down here, and it's basically like the scan line essentially. So that's what that's doing. I'll turn it on. Hopefully it works. I've had a few issues because these 3 breadboards here, they're actually terrible breadboards. They're really crap. They have really bad connections, and even when they're working, sometimes you can see issues appear on here. So instead of just doing one column, it will do multiple ones because something here is flickering really fast. When it's working, it's just one column lit at a time, and that's perfect. So hopefully it's doing that. I just tested it, but sometimes if you leave it alone too long, it just decides to stop working nicely again, and you have to jiggle bits around. So let me turn this big light off, and I'll turn this on. So I'll start from the clock actually and just go through each bit. Yeah, it looks like it's working perfectly. So yeah, as you can see, the clock there is doing 2 ticks, and both of those are fed into the single input using some diodes here. So even though there's two there, it's every time one lights up, it's just the same signal, which goes into here. So as you can see, that's flipping between 0 and 1. But every time it hits 0, this one counts to 1. And same here, this one is clocked into this one. So if you can see, when they're all red, that's 0. When they're all green, that's 7. So we'll count through it. So you have 0, 1, 2, 3, 4, 5, 6, 7. Perfect. And you'll see here the LED matrix. Oh, I don't know if you can. Oh yeah, I'll zoom out. So as you can see, it's counting across that way. And you can see it's lighting up different ones each time. Actually, I'll probably turn a light on that and make this a little bit. I'll just turn it down, that might make it a bit better. Yeah, that's probably a bit better. So what I'm going to do now is I'm going to take one of the capacitors out here, and this will speed up the frequency. Hopefully I don't knock everything over. Right, so as you can see, that basically, well, you can only see one light there, but it is ticking between them. That's flickering very fast. You can't see it on camera, but it is. And if you look here, let me turn the light off again. It's sort of meant to be drawing a smiley face. If I take out the other capacitor as well, it works a bit faster. And it should appear a lot better. Yeah, that's perfect. That's better than in real life. It's a bit too bright looking at it with your own eyes. But yeah, that's really good. I'm happy with that. It works. And everything just looks like it's on here, but it's actually just ticking really fast. Oh god, look, it's breaking. I don't know what happened there, but it started flashing for a second there. Oh well, let me turn this back on. So I can actually just bung these capacitors back in. I don't need to turn it off or anything, and it will slow down again. So, hold on, let me get it. Is it that one? Yeah, it's there. So just bung them back in, it slows right down again, and voila. So that's my first pretty large electronics project. Have plans for loads more. I could finally take all this apart and get rid of it, and make something more interesting. But thanks for watching, and see you later.